Hey class, it's Mr. Woodbury, and in this segment of final reviews, we're going to go over the one mean test. Now there's a test for a population mean. There's also the sign test, which ends up being a test for a population median if the conditions are not met. Let's jump into the first one. I know it's a hypothesis test because I'm asked to test a claim with a certain level of significance. I have one set of sample information, 36 customers, monthly bill of 1918, given a population standard deviation. Mean standard deviation in size tells me we're dealing with a mean problem. Also, if you think about collecting the data, if you would ask somebody for their monthly long distance bill, you're going to get a numerical answer, not a categorical answer. Finally, we're comparing a population parameter to a certain number, not a percentage. That again screams mean. So everything here says this is a one mean test. Now, since we don't have actual data to work with, we don't have to worry about outliers. Technically, we would have to multiply the sample size by 20, but that would only be 720 customers, and we assume that a company would have a lot more than 720 customers. So we're going to go ahead and do this as a one mean test. This is going to be one mean with summary because we already know the mean, standard deviation, and sample size. The null hypothesis for a one mean test compares mu to a certain number, and here that number is 20, the $20. For H1, it's also going to compare mu to 20, and we look in the problem for the sign. Here it's that it was less than 20, so mu less than 20 is our alternate hypothesis. The level of significance given in the problem this time is 0.01. Remember that as that level gets smaller, we use those cases for scenarios where we can get in some trouble if we make a mistake. So if it's a matter of life or death, somebody could get sick or hurt or worse, or we could get sued, we want that number to be low. If it's something that's not important, that number can drift up a bit. Typically we use 0.01 for the real serious ones and 0.05 above that. The test looks like it's a one mean test, and we don't have conditions to check here, so we're going to do it that way. In the next step, we're going to calculate a test statistic, which is t, and we're going to come up with a p-value. From there, we'll make a decision about the null hypothesis. So we'll either reject or fail to reject HO. Then we'll make a conclusion about the claim, about the H1. There either is or is not sufficient evidence to support what H1 says. And here, H1 is that the mean is less than $20. To support that, the mean bill is less than $20. Now, before we jump into Statcrunch, we do need to make note of a few things from the sample. The sample mean is 1918. The sample standard deviation, $3.87. The sample size, 36. Notice how that's all within the same couple of sentences there. Be careful not to confuse the 20 and the 1918. The 20 is what we're comparing the population to. The 1918 is the number that comes from our sample. All right, let's go ahead and switch over to Statcrunch. Stat T, one sample with summary, because we don't have the data to work with. The sample mean was 19.18, the standard deviation 3.87, and the sample size 36. For the null hypothesis, we had that mu was equal to 20. For the alternate hypothesis, we've got mu is less than 20. Press compute. Our test statistic is -1.27, meaning our results are a little more than 1.25 standard deviations lower than we expected. Now, we know from our past experience that's not that unusual. The p-value is 0.106. So let me write that down, and we'll cut back to that screen. So the t statistic, -1.27, the p-value 0.106, because that is not below 0.01, we fail to reject HO. And that means that there is not enough evidence to support H1, that the mean bill is less than 20. Let's try one more one mean test. 8 artichoke plants at a farm were selected at random. Here are the number of artichokes produced by each plant last year. At the 0.05 level, test the claim that the mean number of artichokes is higher than 30. Okay, this looks like a one mean test. I've got a level of significance, 0.05. I'm asked to test a claim comparing a mean to a certain number. However, if the conditions don't work out, I have to pivot to the alternate test, which is the sign test. So I'm going to begin by writing it up as if it were a one mean test, and then I can make some adjustments as I go. The null hypothesis, what value are we comparing the mean to? 30. So mu equals 30. For H1, what sign belongs between mu and 30? We're saying that we're trying to show that the mean is higher than 30, greater than 30. The level of significance, 0.05. And as I mentioned, this looks like a one mean test. However, as we're about to see, this one fails the conditions, and I'm going to have to make a couple of changes. When I do, let's try this color. When I do, the first change is instead of mu, I'm now going to be working with M for median. And instead of a one mean test, I'm going to be working with what's called the sign test. That's a non-parametric test that does not depend on a normal distribution. Okay, let's go over to Statcrunch. I've already typed the data in. These values are in this sheet inside of our group page. It's called Zoom Final Review, and that's available to you. The column headers list which problem number we're working with here. Problem 8, artichokes entered in this column. Okay, I'm going to start as if it's a one mean test again. Stat T, one sample, this time with data. Select the column that has the data, artichokes. The null hypothesis was that mu is equal to 30, and the alternate was that it was greater than 30. To check the condition, I need to ask for the box plot with mean marker. Press compute, and there are the results of the test, but let's look at the graph first. And when we look at this graph, we can see there are a couple of outliers, one on each side. That means that we can't use a one mean test, and I can ignore everything that was on that first screen and start over. I'm going to start over under stat with non-parametrics sign test. The alternate test for the one mean test is the sign test. Select the column again, artichokes. Now notice what the null hypothesis says, that the median is equal to 30. For HA or RH1, I switch it out to greater, just like in the last one, press compute, and there's my p-value, 0.0352. Go back to this screen. When we perform an alternate test, all we need is the p-value, not the test statistic. So the p-value again, 0.0352. We're comparing that to 0.05. It's lower. So in this problem, we're going to reject the null hypothesis. The belief that the median was 30, we're saying that we believe it's false. That means that there is sufficient evidence to support what H1 says. And here is that the median, not the mean, but the median number of artichokes is higher than 30. Again, I had to switch that out to median because the sign test is a test about median, not mean. All right, so that's an example of a one mean test that was done with summary data, a one mean test that was attempted but discarded with numerical data because it failed the outlier test, and an example of how to do the sign test. In the next video in the series, we're going to take a look at the two proportion test. We'll see you then.